Welcome to Summarize Science, where we break down complex research. Could an AI replace an astrophysicist? A new study puts that idea to the ultimate test. Researchers wanted to know if cutting-edge AI could do more than just answer questions. Could it replicate an entire scientific discovery from scratch? To find out, they created a challenging benchmark called ReplicationBench. The core idea is simple. If an AI is going to be a useful research assistant, it must be able to faithfully and correctly reproduce existing work. They chose astrophysics because much of the research is computational and data is widely available, making it a perfect testbed. The setup was rigorous. The AI agents were given 19 real, peer-reviewed astrophysics papers. Their mission was to use the manuscript and the original datasets to independently reproduce the paper's main conclusions. This involved everything from setting up the experiment to analyzing the data and writing the necessary code. These weren't simple textbook problems. The tasks were broken down directly from the papers themselves. Some were straightforward, like counting a specific type of star in a dataset. Others were incredibly complex, like calculating the evolution of a star's orbit or comparing simulations of the universe. The results were unambiguous and quite surprising. Current frontier AI models failed spectacularly. The best-performing agent, Claude 3.7 Sonnet, achieved an average score of just 19.3%. As you can see in Table 2, none of the models came close to passing this test. This highlights a huge gap between an AI's theoretical knowledge and its practical application in a real research workflow. The study didn't just score the AIs, it analyzed why they failed. They identified 3 primary failure modes. First was a lack of persistence, where agents would give up prematurely. Second were procedural errors, where the AI misunderstood the scientific concepts and applied the wrong methods. The third was technical execution failures, which included coding mistakes and an inability to handle large datasets. So, let's recap the key points. Researchers developed a novel framework, ReplicationBench, to evaluate AI's ability to perform end-to-end scientific research. They discovered that even the most advanced AI agents are currently not capable of reliably replicating complex astrophysics papers, scoring below 20%. The failures were not just simple mistakes, but fundamental issues with persistence, conceptual understanding, and technical execution. What does this all mean for the future? This study provides a crucial, sober assessment of where AI stands in the scientific world. It's not about saying AI is useless, but about highlighting the need for better evaluation and development. ReplicationBench provides a scalable way to measure progress and pushes the field towards building AI that can be a truly reliable partner in scientific discovery. Thanks for tuning in to Summarize Science.